I would expect total compensation to be around $400,000 a year. Rust is the most desirable language, and I think part of it is because
AI is overhyped. Why do you think so?
I don't think it can understand. Oh, Rust is better than Go because it has types.
Blockchain, Web3.
Roughly speaking, gambling. I think my primary driver for moving away from the US was
Every great tool starts with a problem, especially programming language. Jon Gjengset, what problem was big enough to create trust?
one of the early slogans for Rust was this sort of safe, performant, ergonomic, or usable. Can you get all three, or do you always need to trade one of them away? And it tries to give you all three of them at the same time. And traditionally, that's been very hard to achieve with a programming language. Like if you want it to be ergonomic, then often you give up speed because you need to have a runtime and a garbage collector. So Rust was trying to sort of thread the needle of getting in between those.
Jon Gjengset, Rust live coder and evangelist. PhD from MIT, ex-Amazon. Now principal engineer at Helsing, the biggest AI defense startup in Europe.
You did your PhD at MIT, and that's, well, engineering school #1. It's intense, it's isolated, it's brilliant. So was it that way for you?
The feeling I had at MIT was very much one of like collaboration and curiosity, of everyone just wanting to know stuff and to learn stuff. So I ran a board game night at MIT for many, many years, and a lot of the conversations we ended up having was just like while playing games was about, oh, what's your research about? And, oh, tell me more about that. And learning random facts about other fields of science. And that's really fun. But there was a culture of that being like the exploration, the curiosity, the interest being a core part of being there. And then, of course, you have a lot of very smart people, both professors and students. And there was always almost all the professors have like an open door policy. You just walk in, you can talk to them about anything, and they're interested in engaging in the conversation. So it felt like a very collaborative environment. So a lot of the work that I did during my PhD was work that was like in the open source space, in the Rust space, because that's where I felt like I could expand my learning and also try to teach some of the things I was learning. And I had the space to explore using a new language because curiosity is king in a way. There was no pushback internally in my lab or from my professor to go try this brand new language for what was going to eventually become my PhD thesis project.
So did you start using Rust there?
Yeah, so I started using Rust for the second prototype of my research database. So the first like draft of it, which I threw away after a couple of months, was written in Go. You know, I exported in Go and then realized that I wanted to design the system differently because I wanted the database to look different. And so it wasn't I don't want to use Go for this. It was more of I need to rewrite this anyway. And then I saw the Rust 1.0 announcement like a few months prior, and I was thinking, well, this is going to be a highly concurrent code base, and I think programming languages are interesting, so what if I just try doing it in this language? And then I just never stopped.
We've got recently results of Stack Overflow survey, and Rust continues to be the most admired language for already 9 years in a row. But if we look like how many developers use Rust, it's like 12, maybe 14%, so not that much. What is the #1 reason for that?
So I think the answer almost lies in the question, in that Rust is the most desirable language. And I think part of it is because people don't get to use it as much as they want to. It could be that if adoption was much bigger, the number of people who want to use it goes down. So it's almost like because they're denied access to it, people want it more. That could be a part of the answer. But I don't think that's the end of it, right? I think that's just a facet to the answer. I think the other part of this is the biggest barrier to adoption maybe is momentum in existing companies. Adopting a new language is seen as a big cost because it is, right? You have a bunch of talent already at your company that know the existing code base, the existing language. And if you were to switch Rust, all of those people would suddenly need to learn Rust, which is a huge investment. But not to mention all your current code is not Rust. So you either need to translate it, or over time you need to build up like replacement components, or you need to start like porting it bit by bit. And all of this is like a very costly endeavor. And so I think it's the switching cost is so high that most companies are not willing to do it unless there's a very, very strong reason. And to be fair, we are seeing some companies go down that adoption path. Like big players like AWS, for example, are starting to build big components in Rust or replace existing components with Rust. But it's a gradual process. You can't do it all at once. And so as a result, you end up with this slow adoption curve. And I think it has to be.
Does it have something in common with this learning curve?
I actually think adoption is not that related to the learning curve. Like, I do think Rust has a peculiar learning curve compared to many languages, but it's not clear to me that that's the barrier to adoption. I think it's the barrier maybe to why there aren't more Rust programmers, maybe, but I'm already seeing a lot of interest in Rust, especially from junior engineers, but also from senior engineers. And of course, juniors become seniors over time. But I don't think that that's the reason why companies will not adopt it.
So after MIT, you joined AWS. You worked on some Rust-built infrastructure. And what kinds of problems you were solving there?
So at AWS, my job was to develop and maintain and support the Rust build system at AWS. So any Amazon codebase built in Rust was using my build system to build all of their Rust code. Over time, that started out as adopting a sort of grassroots build system someone had built internally, and growing that into a more mature internal tool. And then over time, it included things like working with security to make sure it integrates with all of the security tracking and provenance information and all of that stuff, improving the ergonomics so that it works with IDE integration and getting good debug logs and build logs and test logs, all the way up to how do we make the user experience really good so that you can actually run standard cargo tools rather than something completely custom that's to be built just for AWS.
Was there any internal resistance?
Amazon is an interesting company in that there's very little mandate for what language you use. It's not like people tell you, you must use this language. At least that's uncommon. People choose language based on need, and very often the answer to that is Java. But that's because so much of AWS is already built on Java, so there's like supporting libraries for everything, the infrastructure for telemetry and debugging and logging and build system, like all of that stuff is so well built out. And so it's very easy to integrate with everything by using Java, and we have a lot of engineers that use Java as well. And so the pool of people who can work on that and for whom that's the language of preference was large. And then I think Kotlin is a close number two, like people are increasingly wanting to use Kotlin over Java because it's a better experience. But that also meant that it was very easy for people to go, actually, we want to use Rust now. And then this grassroots build system for Rust popped up, and then people started using Rust. And it grew to the point where there was sort of a decision to invest in, okay, let's officially support this language internally now.
So you like Rust, and you work on introducing it, and then it looks like some people are supposed to use Rust.
It's actually the other way around. It's the other way around. It's not like I went to teams and tried to encourage them to adopt Rust. It's that teams came to me and said, we would also like to use Rust. Help us do that.
Okay.
So the drive was very much from the teams who wanted to use it. There wasn't really a need for a push operation because we already had so many people wanting to use it.
Was it the right decision to switch some certain parts of codebase to Rust?
In a way, I'm the wrong person to ask, right? Like you would have to ask the teams that ended up using it and ask about the pain they've gone through since. But in general, I think there's been a huge success story to it, especially in terms of like latency and tail latency in particular, because Java and Kotlin struggle with this, like when you have a runtime and a garbage collector, it's so easy that your tail latency ends up increasing quite a lot, or your minimum latency is decently high because of startup costs. Whereas with Rust, many of those problems almost go away by construction. So I don't think I've at least heard a lot of we regret the choice of Rust there. Quite to the contrary.
All right. Some people say that Rust was created by geeks for geeks, and business interests came second.
I don't think it's because Rust is not designed for business. Because certainly we see it adopted at huge scale at AWS, at Meta, increasingly at Google with Fuchsia. So it's not as though it's not being used for business things. But it is the case that it's a newer language, and all of your stuff is not written in Rust today. So it's more of a question of willingness to rewrite, access to talent, access to training for your existing folks, and even just sort of maturity of the ecosystem, right? It might be that you need a library that does something very specific to the protocols you implement, and that just hasn't been built in Rust, or it's been built but it hasn't matured, whatever it might be.
Like, for example, there was a case with Discord. They started rewriting everything to Rust, and they had a huge code base in Go, I think. And then at some point, they stopped this transition. What actually kills migrations, like, to Rust?
It's hard to try to draw a generalized lesson from something like the Discord story, because we don't know behind the scenes what bottlenecks they ran into when trying to do this migration. There are some places where Rust is not a great fit. Like, for example, if you really have to interface a lot with C++ heavy code bases, like you have to do extensive integration with, let's say, CUDA and Intel DPDK and some hardware vendor driver library, and also with like Unity or something, that's a bunch of C++ dependencies that have a lot of infrastructure around them. And so if you had to interface with all of those, trying to put Rust in the middle is going to be a lot of pain. And it's unclear whether the gain is worth the cost. So that can be one example of something that might make you hesitant to adopt Rust in that space. The other is if you have a very battle-tested application that doesn't really need to change very often, and it just kind of works. Rewriting it is always a risk, like whether to Rust or something else. And the question is, if you already have a well-behaving, robust application, is it worth changing it? And many times the answer could be no, or at least no, not at the moment. It could be that they ran into some parts of their code base where that was the case. It could be that they ran into a hiring limitation, right? Like they don't have enough Rust programmers for everything to be Rust yet, right? And so until they've hired to that point or trained their existing folks to be comfortable owning Rust code bases, they just can't they make the move because they need people to maintain the other parts. And it's hard to say which of these things they ran into.
AWS, it's kind of like they have their own specific tasks and beyond AWS. Like, are there areas where Rust is really successful? Like which industries or tools are clearly like betting on it right now?
The areas where I've seen the most eager adoption of Rust is embedded development. I've seen a lot of Rust. So for embedded development, like really low-level embedded development where you want to directly program an ESP32 or something, Rust has seen a lot of adoption because the choices you have are C or C++ or Rust. There's not a whole lot of other options. And when given the choice between those, people would rather a more modern, safer language that has good support for third-party ecosystems than C and C++. And so the entryway into that space was pretty easy. I think the second one we've seen a decent amount of adoption is actually in command line tools. So Rust is, and this is partially due to there's a crate called Clap that makes it really easy to build command line interfaces. And so that, I think, spurred on a lot of people going, oh, I'm just going to write this command line tool in Rust because it's easy. Safety critical applications is the other space. So that's both in the defense sector, it's also in the automotive sector, and to an extent in sort of space operations as well, where you really need systems that are very, very robust. And traditionally, those places don't use runtime languages. They tend to be like C or C++ shops. And what Rust is promising over C and C++ is addition of safety. And so that is a very attractive proposition for safety critical applications. And it's sort of one step less than going to something like Ada, for example, which feels like maybe too much of a burden on developers, at least for a subset of these systems.
if your goal is to pitch Rust to some Go team, maybe like in one sentence, what would you say to them?
To a Go team, I think what I would do is something like, isn't it awful when your application crashes at runtime because you made an error? In Rust, that is much less likely to happen. I think the argument is that simple. And it's one of those where people don't believe you at first. They go, well, I don't get null pointer exceptions in Go. Well, you kind of get nil pointer exceptions roughly. Or like, I don't get double freeze. That's true. You don't get like freeing allocation errors and stuff. But you do get a lot of business logic errors. And Rust can help you with those too. Right? It's not as though Rust only helps with memory safety. The expressive type system also means that you can establish more guarantees at compile time. And that makes you way more comfortable with the code you've written being actually correct, and much less likely for your code to be wrong at runtime.
I like this game, like C++ team. What would you tell them?
I think for C++, yeah, if they're ready to listen to you. I think for C++, the argument goes something like, okay, no use after free, no double freeze. You don't have to worry about freeze. It just happens automatically. You get that a lot already in C++ just because of RAII. But what you don't get as much of in C++ is concurrency safety. So in Rust, it is very hard for you to have concurrency bugs. In C++, it's very easy to have concurrency bugs because there's nothing that helps you get them right. You can run like address sanitizer and thread sanitizer and all of that, but fundamentally, those only detect the errors that do happen, like that actually manifest in this particular execution, whereas Rust can exclude them at compile time, statically. And that is a major difference for anything that's a concurrent program. So I think that's the primary argument for C++. And then the secondary argument is, wouldn't it be nice if you had like a good build system with third-party dependencies? And then they cry.
You spent almost like, I think, a decade in the US, like PhD at MIT, then Amazon. And then in 2023, you moved back to Norway. So why did you decide to move from the US to Europe?
I think my primary driver for moving away from the US was I don't really like the US. What I mean by that is there are a lot of things that I found that I appreciate in a society. And I mean society here not as in the people, but in the things that the society and the societal structure around you provides that I don't see in the US, but I see in Europe. And I could sort of start a laundry list of the things in the US, right? But just to take one example is the way that healthcare is approached in the US. Makes me really upset. I don't want to live in a society that operates healthcare that way. And then there was sort of a large number of those things that actually meant that when I finished my PhD was when I was planning to move out of the US. And then my partner wanted to move to LA for work. And so we decided, okay, let's do that for a few years. And then after a few years, we went, okay, it's now time to leave. And at that point, we then left for Europe. We were debating whether we would move somewhere else, but I have family in Norway. It would be nice to sort of move back and see, can we establish something here? Too early to tell whether that is going to be the permanent place either. I genuinely don't know. But it was more of a, well, I don't want to be in the US. And the alternative, the primary alternative seems to be Norway because I have connections there. We'll see how that goes, and worst case, we'll move again. But I tend to be a person who enjoys to move anyway, so I consider the threshold or the barrier to moving quite low. So moving and then moving again is fine by me.
Was it easy to find the Rust role in Europe? And maybe in general, like, is there a difference between US market for Rust developers and European market?
There's certainly a difference in the markets. The US tends to be more remote friendly. Like especially a lot of the tech companies in Silicon Valley are happy to hire anywhere in the US, outside the US often as well. Whereas it seems like European companies are slightly less happy to hire remotely. The salary is lower in Europe in the computer science sector. And I think the other difference maybe is there are just fewer companies in general in the tech sector in Europe than there are in the US. And fewer of them seem to be using Rust. But certainly when I when I was moving from the US to Europe, I put out a sort of announcement on social media and everything that I was moving and looking for work. And I got a lot of companies that reached out, including a bunch from Europe. So it's not like they don't exist.
So as you mentioned, salaries. So our team looked up numbers. So in Norway, a senior Java developer make around 94K a year. What's the realistic range for Rust engineer in Norway?
Very hard to say. I think that the salaries vary quite a lot. But part of it is also whether you're working for a startup or a more established company, right? Because for a startup, you tend to get paid less in terms of cash value, but then obviously you're betting on the startup doing well, and so you get paid a bunch in equity that's not worth anything unless the company does well, in which case it's worth a lot. And so it's hard to say what the expected salary is, because I also think Rust is more likely to be used in startups, which sort of pulls the expected compensation down. My expectation would be that it's somewhere around 150 maybe for like senior Rust person in Norway would be my guess. Whereas if you're in the US market, a senior Rust engineer, you would be paid, like let's take Amazon as an example. I mean, these are slightly dated numbers now since when I left, but I would expect total compensation to be around $400,000 a year. So it's like a significantly higher salary. Dollars, not euros, but they're not too far apart. The downside, of course, is you have a lot more expenses of things like healthcare and everything, but even adjusting for those, I think the salary is just undeniably higher in the US than it is in Europe.
And also vacation days.
Yeah. I mean, don't get me wrong. I would much rather work here than in the U.S. But just focused on salary, the salary is undeniably higher there. And then the question is like, how much? Well, like, what is those extra dollars or euros worth to you? And to me, they're not worth the things I'd be giving up. Which is one of the reasons I moved.
You joined Helsing, which is a European defense AI company. Mm-hmm. And with this defense thing, some people were like in community were cheerful, but some of them were uncomfortable.
Oh, it's funny because I'm also uncomfortable with it, right? I would expect everyone to be uncomfortable with the military and with the defense sector because it's inherently an uncomfortable topic for humans. So like, I was not at all surprised really that people were uncomfortable. If anything, that's sort of the reaction I expected.
What Rust has in this area?
I think it's, in a way it's obvious, right? Like this is a sector where safety criticality is, well, critical, right? It really is safety critical. If you get things wrong, the implications are severe. And so that means you really want to make sure the software you write does what you intended it to do. And Rust helps you do that, right? By statically eliminating bugs, for example. Like an example here is so I recently wrote a Rust library for spatial math transformations, like 3D coordinate system and frame of reference conversions. And the library has almost no code. It has almost no implementation code because it's just matrix multiplies and quaternions and stuff. But what it does is it does type state encoding of coordinate systems to make it basically impossible for you to take a coordinate that's in one frame of reference system and accidentally use it as though it was in another one. And this is the kind of bug where if you didn't have a strong type system, you couldn't express this. You would just have a coordinate type, and you better remember which one is in which frame of reference system and don't use them incorrectly. Whereas in Rust, I can actually enforce this at compile time, which means that I end up with software that's less likely to contain bugs of a certain kind. And then you can generalize this to more and more places where you can use the type system to ensure safety at compile time, and you end up with a program better suited for safety critical applications.
Are there analogous, like similar libraries in Python?
This library that I wrote has almost no implementation code. There's almost no math in there. All the math is in like a linear algebra library. So I'm using NAlgebra in Rust. And in Python, you would use, I don't know, NumPy or SciPy or any of the sort of linear algebra libraries in Python. And you would have the same code, but expressing it in the type system so that you get a variable whose type is, coordinate in ESIF or coordinate in this plane's NED system. you don't have a way to express that in Python. And so you couldn't port this library to Python because porting it would mean removing all the types, at which point the library is empty. So there is nothing to port to Python. There can't exist something like this in Python. And there are a few caveats here around maybe you could do something in MyPy with like not using generics, but sort of long string generated type names something. But in Rust, this is a very natural way to write a program. And so it feels very valuable to be able to make use of it. And I don't see an obvious way you could make use of that in other languages.
In Helsinki, you hire Rust developers. Is it an easy task to find a Rust developer?
So yes and no. There are a lot of Rust developers on the market. What I've found, though, is that there tends to be more junior engineers than senior engineers on the Rust job market, which is a challenge for companies that are looking to grow very large in the Rust space, or even just to adopt Rust for the first time, because what they need are senior engineers that can then guide up the junior engineers. You don't really want to start a company's Rust journey with junior Rust folks. Like, they don't really have the accumulated experience to bootstrap the project in a safe or in a healthy way, right? You need the 1 or 2 senior people first that you can then grow a team around. So at Helsing, we've, I think, been happily been able to hire like a decent number of senior Rust people, but you're still kind of capped on the number of junior people you can hire based on the number of senior people you currently have. So I think the biggest struggle for us maybe has been to hire more senior people, because not because we don't hire the juniors, but we need more seniors to fit more juniors, if that makes sense.
Is your personal brand in the Rust community helping with this goal?
I think so, but I think it's helping in a very particular way. So I think my personal brand here helps in making people curious about Helsing as a company, and it makes them think that it must be an interesting place to work because Jon chooses to work there and talks about what it's like. But I don't think it makes senior engineers who are happy at other companies go, maybe I'll switch company. I don't think it goes quite to that level. And the reality is that a lot of the senior Rust engineers you would want to hire are already employed elsewhere. And so it's not sufficient to make them interested. They also need to be willing to switch jobs. And my personal brand can't do that alone.
When you were job hunting in Europe, you wrote in your LinkedIn, I think, I'm not looking for work in the cryptocurrency, blockchain, Web3, or DeFi spaces. Why is that?
I have this need for the work that I do to feel like it matters in a positive way in the world. That's one of the reasons I do education, is because I think it matters. And I feel the same way about my work, that I want to work on something where I feel like there's a positive impact on the world as a result of the work that I do. And for the crypto space, the work there is super interesting. Like the algorithms, the data structures, many of the like distributed systems problems are fascinating. There's a lot of intellectual depth to them. But I have yet to see why it matters. I get a lot of the theoretical arguments, but in practice, I just don't see them having the sort of promised impact, if you will. If anything, I feel like the places where I see these spaces have found a use is like more negative than positive. And that's not to sort of dismiss the people who work in those industries. Quite to the contrary, I think it's super interesting technical work. But for me, that's not enough.
If someone is looking for a job in Rust, they see a lot of job postings in this crypto area. So what makes Rust so good for this particular thing?
It's something that's fascinated me, of like, why is Rust so commonly used in the crypto world? The best I can think of is that you end up building systems that need to be quite parallel. There's a lot of sort of distributed systems protocols. Correctness is quite important because you're building like things that need to be correct in some way. And so maybe that lends itself to Rust. Maybe it's also the fact that a lot of these things are built from scratch, and so you get free rein when choosing a programming language, and a lot of those people choose Rust. Maybe there's something here about smart contracts and WebAssembly compilation or something in that space, but I still don't know what the full answer to why it's so prominent there. Interestingly, actually, so, crypto both means cryptocurrency, but it also means cryptography. And Rust is also quite widely used in cryptography. And there I see it a lot more, because if you want really secure cryptographic libraries, that feels like something that's worth implementing in Rust to eliminate some of the potential error cases in the cryptography where the impact is certainly high.
The United States, they approved exchange trade funds on Bitcoin, so it looks like they're making it official part of financial system. So do you think that this is somehow like changing how crypto is seen in this world or not? Like for you and maybe in general?
To me, Bitcoin is, roughly speaking, gambling. In the same way that the stock market to an extent is gambling, although you have more insight into the odds maybe. To me, it feels almost purely speculative, in the same way that much of the stock market is speculative. So in a way, Bitcoin being traded, even if it's indirectly on the stock exchange, feels to me like par for the course. That feels appropriate given what it is. And it's not clear to me that that adds any more credence to its value as a financial unit.
On one of your streams, you said AI is overhyped. Why do you think so?
So I'm going to sort of date myself here a little bit, or maybe date is even the wrong word. I'm going to like Luddite myself a little here. I think what's happened with AI is that people are seeing some of the things that are really impressive. And I think they're extrapolating from that abilities that the AI does not have and that it's not trivial to add. So I think that when we look at things like, the output of LLMs has gotten very good, very real seeming, and very fluent. But where it falls short is on things like actually understanding the topic that they're talking about or that they're trying to express. And that to me is not something that's just like one fine-tuning of the model away. It's something where I haven't really seen it get better. I've seen it get better at maybe faking it, but when you ask it for things that are like, there was a recent study where they tried to figure out whether like LLMs or machine learning approaches could find the underlying physics model of like the movement of celestial bodies, and they basically found that no, they can't. They are really good at predicting the positions of planets, but they can't actually come up with what is the underlying principle that's driving it. And it's because they're really good at the pattern replication and extrapolation, but they're not good at understanding that there's an underlying model. And I mean here like physics model, for example, not machine learning model. I expect to see the same thing in agentic AI for coding, for example, where it's very good at producing code, perhaps even correct code, when it can work from examples that already exist, or when it can adapt multiple examples and merge them together. Where it's less clear to me that it can do well are on tasks where you need to understand the underlying program structure at like a deeper level. You need to understand how the type system works. Because, and this is where I'm skeptical, I don't think it can understand. That's not to say that we could never build AI that does that, but I think that's more towards like general purpose AI than the current like LLM-driven machine learning. And so that's where my skepticism comes in. But this is the kind of thing where I also feel like I'm speaking from speculation almost entirely. I don't have the hard facts for this. It's just a feeling. And so one of the things that I've sort of tasked myself with here is to do more, to use agentic AI more, precisely to try to test its limits here. And so I've set myself some like internal boundary measurements for things I think will be hard for it and where I want to see whether it could succeed or not. And we'll see over time whether I manage to prove myself wrong here. I mean, that should always be the goal, right? I come up with a hypothesis, like I don't think they can reason, and then try to prove myself wrong.
But we should admit that AI these days writes more and more code.
Oh, for sure. But I think the question becomes, what code is it writing?
And so what do you think about this idea that eventually it will take all developers' jobs?
Yeah, I mean, that's the thing that I just do not believe. Because, again, I do not think it can reason. I think it can really well replicate structure. It can really well replicate patterns. It can really well replicate even things where there's not really a pattern. It's the kinds of programs that people have written before, and it can figure out how to meld them together to make a reasonable resulting code base, similar to how it can construct complex sentences and documents. But that doesn't mean that the thing it builds is reasonable or correct. I think what it's really good at, and what we should be utilizing it for, is for a lot of that work that is easily replicable, that a bunch of people have done before, have done something similar. Like, let's take interacting with Amazon S3 or DynamoDB or something, where there's so much code written to do those interactions, and to do them in insane ways. And so we should expect that like an agentic AI coding thing should be able to also write code that does that well. And so I would love to use that for that, so that I don't have to go look at all the documentation and look at all the Stack Overflow posts and write that code myself. I can just have it build something for me and then check it. Seems great, saves me a bunch of time. But on the, to take the example from my presentation that I gave at the Rust Amsterdam meetup on Squaba. Squaba is like a type-safe library that's really just type coding. There's no implementation code for enforcing invariance in the type system. Not clear to me that you could use agentic AI to build that, because it requires understanding how the type system works and how you can enforce particular behaviors using it. It's not really following established patterns in that way. But I would love to be proven wrong.
So you're mentioning like quite complicated designs for a library, and maybe for that AI is not that scary. But just imagine like there is someone watching us here, and they have this fear of AI replacing them. So what advice would you give to them?
I think my answer is going to be split here. I think the fear to an extent is real, because there are software engineering jobs that I think machine learning can do really well. Like if your job is designing WordPress templates, for example, is something that where there are a lot of examples for machine learning to learn from. So there's a lot of pattern replication it can do to produce things that are reasonable. It's not like the resulting thing requires that you have a deep understanding or develop some new intuition. It's really just pattern replication and then figuring out how you mutate the pattern to make it look the way the user wants. There, I expect that it's going to be very hard to have a job as a template designer for WordPress in the coming years. That seems to me like something that's probably going away. On the other extreme of the scale, right, if you're writing research papers about new like snippets of assembly code that perfectly optimize doing a fast Fourier transform, not clear to me that you could just prompt that to the agentic AI and it would give you better assembly. That seems to me unlikely. But then there's a whole spectrum in between, and the question becomes, like, where does the agentic AI go from it completely replaces your job to it replaces a part of your job to it's a tool that can help you to it's completely useless? And I think that we have the whole spectrum, and figuring out where you sit on that spectrum is difficult. But I think part of what will happen is, I saw a good example, I think it was on Blue Sky the other day, of someone saying, quitting your job as a software engineer now because of agentic AI is like quitting being a carpenter because of the sawmill. It makes no sense, right? It's a better tool that we can make use of, and hopefully that means you're now capable of building more interesting things. So lean into this, right? Like, let's say that you're a developer who builds WordPress templates. Maybe now the agentic AI can build all those WordPress templates for you, and the thing that you get good at is building tooling for users to build their WordPress template themselves. So you take one step up and build the thing that uses the tool. Think of it as a utility that you can use to make your craft better and to improve what you're able to deliver as value, rather than as this will be a stand-in for me and therefore I'm now out of a job. But I do acknowledge the fear, right? Like this is a disruptive technology. There's no doubt about that.
Let's focus on AI and Rust specifically. Do you think that applying generative AI to Rust is somehow different to applying it to some other programming languages, like generating Java or C++ or Python?
I do think generating Rust code is probably harder for LLM-style AI. And the reason this actually relates to one of the other things we talked about, which is this idea that Rust has an additional mental component to many other languages. Like there's a fundamental concept at Rust of this idea of lifetimes in the borrow checker that other languages don't have. And it's something where we see this with programmers who don't have that understanding, that mental model of the borrow checker, trying to write Rust as though it's some other language with different syntax. And then they immediately run into problems. Like it becomes really hard to write the programs they want to write. And the reason for that is because they're lacking that understanding, and they're trying to write a program absent that understanding, and then it's just wrong. And I think we will see the same thing with AI, that when writing Rust code, they also need to, if not understand this other piece, be able to at least faithfully replicate it, or replicate it well enough that they produce a correct program. So that it's not that it's impossible for it to do so, but it increases the complexity of the task.
Is it possible to use Rust as a basis for AI infrastructure? Like we know that a lot of things is implemented in Python right now, and Rust is used with Python in many projects. So can we use it for AI?
So I think we can, but I think there's an interesting question of whether we should. So where I work now, we use machine learning both in production, but also for research. And the reality is that I don't think we want to use Rust on the research side, because for machine learning researchers, it's not clear to me that Rust is the right language. They do a lot of prototyping, rapid iteration, building things and throwing them away, and Rust isn't really built for that, right? As we talked about earlier, Rust tries to force you, it gives you the headache up front. It tries to force you to think carefully through your program to make sure it's completely correct by the time it runs. But when you're iterating on like an idea for how to restructure your model or your training, that's not important. What matters is that this run does something, and you can look at the results, and then you can iterate. And so Rust doesn't feel like the appropriate language. Not to mention, all of the research out there in AI and machine learning tends to be Python-based. All of the libraries that people write tend to be Python. And so I actually think we should lean into that and say, on the machine learning side, we want people to keep using Python. On the production side, though, like you don't really want to deploy Python in your car. That seems unwise. Certainly in like anything that resembles the safety critical systems or self-driving systems, you don't want Python there. You want a language like Rust. And so the question becomes, how do we bridge the gap? How do we take the output of the machine learning research and make it usable with Rust in production? And there are ways to do this, right? You have things like Onyx Runtime that lets you build a model in Python, but use it from Rust. You have things like Candle that allows you to basically do PyTorch in Rust, and so you can port the Python code-ish to Rust. So there are a bunch of mechanisms here, and I think that's the way to approach the problem is, I want to use Rust for more machine learning bits, but only for the part after the research has happened. And so I want us to focus on making that experience as good as it can, rather than trying to make all the machine learning researchers use Rust instead of Python.
Let's speculate a little bit and take a 10 years horizon. Do you predict any changes in how human software engineers work in 10 years?
I think the answer to this depends on how wrong I am about my Luddite approach to AI, right? If it turns out that actually machine learning models and the agentic AI we have is or will become really good at reasoning, like they'll be really good at just flawlessly making changes from the beginning, or requiring very little prompting to get to even very sophisticated software systems, including things that are innovative, that haven't been built before, being creative, then yes, I think things would change a lot. I'm skeptical that that will change in the next 10 years. I think what we will probably see is the tooling getting so good that you can accelerate yourself a lot by using these tools, especially for repetitive tasks, tasks that look a lot like what other people have developed in the past. Stuff like, I recently wrote a Slack bot for playing a particular card game through DMs to Slack. That thing, not super complicated. Like a bunch of it is just figuring out how to interact with the Slack APIs, encoding the rules of the game, and then hooking it all together in like a thing that runs an Axum web server that listens to API events. That thing I could probably vibe code without too much problems. And I think in the next 10 years, I could probably do so very quickly and efficiently. These days, my guess is I would need to do quite a lot of coaching to get it to work end to end, but I probably could. So I think for a lot of things that we build either for fun or as throwaways or things that resemble production systems that have built a lot before, I think this is an accelerator for existing software engineers that we will only see grow bigger and more widely used. And that, of course, does change the makeup of human software engineers. It changes our job in a way for at least on the sort of spectrum from very, very straightforward, repetitive, almost like copy-paste work to very innovative research. It changes where on that spectrum people use more of agentic AI, but I don't think it's going to tip all the way over where human software engineers just become prompters or just babysit a bunch of agentic AI. I think that will happen for a subset of the space, but I don't think it's going to replace what everyone does all of the time.
You are optimistic about the future.
I don't know whether I'm optimistic or pessimistic. I think it depends on the topic. I think for software engineering and AI, I'm optimistic, but it's because of this assumption I have maybe, or speculation I have that AI is somewhat overhyped, and therefore, I don't think it'll be as bad as people think it will be. But I think it's partially also a mentality thing that I see this as a tool that I can make use of rather than something that is out to replace my job. But part of that also comes from a position of privilege, right? Like the software engineering that I do is fairly involved maybe, or it's like further on the spectrum towards doing new stuff, things that require a decent amount of creativity or new thinking, whether it hasn't been done before, where I'm much less worried that agentic AI is going to do that thing that I think I have a knack for. And so therefore, I can afford to see it as a tool. I think if you're more on the boilerplate, copy-paste type work, then I think I would be more pessimistic maybe. But for the industry as a whole, I think I'm optimistic.
Okay, now we have several questions. As I said, like Rust via some other programming language. Mm-hmm. So we expect to have some fun content here.
Okay.
Where Rust is really better than Go?
Oh, Rust is better than Go because it has types. This one's super easy. So Go, when they made Go, they chose to ignore basically all programming research from the past, like since the 1970s. And when they made Rust, they decided to learn from programming innovation in programming languages since the 1970s. And so you ended up with a language that is, yes, more complex, but also way more fun to write and way more expressive. And that to me is like the big difference. And the reason why I don't want to use Go.
Are there reasons where you would still choose C++ for your project?
I would use C++ if I have to interface with a bunch of other C++ projects extensively over time. So if I have to integrate with all of this like complex C++ stuff, I don't really want to maintain all the Rust bindings. The only exception would be if I expect that I need to use the same C++ project or library in a bunch of Rust code bases. Then I would swallow the pill and write the Rust like bindings once and then just do Rust for everywhere. But if it's just like one project that needs to interface with 1, 2, 3 big C++ projects, I would use C++.
So what do you think about this statement? Rust is only for those who write C++.
No, I don't think this is true. Quite to the contrary, actually. I think if you're writing C++, you already have a language that's fine for you. I think you could do better, but it works fine. I actually think Rust is even better for those who come from a Java or Go or JavaScript background where you realize you've hit the borders of what you can do with this language in terms of performance, in terms of expressivity, and you want something that is actually way faster and safer and more expressive. And Rust gives you all those things. So it's almost the sell is easier to those coming from a more dynamic programming background.
What Rust feature annoys you the most?
So I think there are two answers to this. The first answer to this is the borrow checker, because it is the thing that I run into issues with the most. I still love it. I still want it to be there, but it is the thing that annoys me the most. I think, more realistically, the answer is I still find the experience of finding third-party dependencies for things frustrating in Rust. Not because things don't exist, but because many of them are like one person wrote it because they needed it, and then they haven't touched it in 3 years because they stopped needing it. And so there's a decent amount of libraries. Like, I think at this point you have library implementation for lots of services and APIs out there, but so many of them are like not widely used and therefore not super well maintained. And that I run into time and time again, and it makes me sad. But I think it's something that gets better as you see more adoption as well. So I'm not really concerned, but it does annoy me because usually these libraries work fine. They're just like, they haven't been updated in ages. So I'm using something that's old and not really thought through, and I know it can be better, and that annoys me.
Many people say that it's difficult to learn Rust. So what's the hardest moment there when you're trying to learn it?
I think the biggest thing is because Rust is not just a different syntax for the languages that people are used to, right? If you were to move from Java to Go, or to an extent like C++ to Go, those are syntactically different, but they feel very similar in the sense that you don't really need to learn new concepts. Maybe you need to learn about what a Go routine is, but it's not that complicated, or what a channel is. It's not that complicated. Whereas with Rust, you need to like learn a new skill almost. Like there's a part of your programmer brain that you haven't built yet, and it's the borrow checker. Like most developers do not have a borrow checker in their head. 1
second. We have some Reddit comment here. Let me read it, actually.
Okay.
That's exactly about borrow checker. So I've wanted to learn Rust for a while now, but I got discouraged because people on the internet say the Rust borrow checker is tough to understand. This made me unsure about learning Rust, and I'm kind of scared to even try. So could you explain the borrow checker for this guy on Reddit?
Okay, so I think this is a great question, because in a way, my answer is yes, the borrow checker is hard, but it is a great way to make you a better programmer. Like the way in which you write C and C++ code without making mistakes is that you start to develop an internal borrow checker. Like if you talk to really good C and C++ programmers, they haven't this idea of, oh, it's not safe to free this thing here because it's still used somewhere. Or, oh, you can't use this here because it's already been freed. That is a borrow checker. So what they're doing in their head is borrow checking, but a weak version of it. So in a way, that's a skill that you kind of need to start learning in order to write in at least the languages like C and C++. In garbage-collected languages, this is not a skill you really need at all. Rust forces you to learn that skill, but I think it's a skill that makes you a better programmer, because it gives you a better sense of how data flows through your program and when different parts of it are used and needed. And that gives you, in turn, a sense for what is the right decomposition for your program. So it is an additional thing to learn, but I think it's a worthwhile thing to learn. And certainly my experience has been that, at this point I have a little talking borrow checker in my head, and that one makes me better at writing JavaScript code, Go code, C++ code, because that information that it gives me is useful in those contexts too.
So can you give me like 3 examples of how you are a better programmer if you have that borrow checker in your head?
Yeah, so in JavaScript, for example, one of the things you want to be careful about is making sure that you don't end up with a memory leak in your application. And the way you do that is you think really carefully about when something might be collectible by the JavaScript runtime. And the way you do that is you think about which things are alive and which things have references to them. There's no representation of that in the JavaScript language, but it is information that's used by the runtime to figure out whether it's safe to free something. So by having a sort of mental mapping of the lifetimes of the variables and objects in my program in JavaScript, I make fewer mistakes that mean that I get a memory leak in the first place. It's not perfect because the language isn't helping me the way Rust is, but it does help. In Go, it doesn't help that much for like performance optimization, but where it can help is for things like Go decides whether something gets heap or stack allocated automatically. And it does so by doing escape analysis, right? Like, is this variable that I allocate inside of a function, does it escape outside the function? If so, I will heap allocate it for you. I will box it for you in Rust terms. that happens behind the scenes. Go doesn't tell you whether it does that or not. But the borrow checker in your head does. Because if I return an object from inside a function, then in Rust that would be illegal. It would tell you, well, this gets destroyed when the function ends, and so you're not allowed to return it. In Go, that's allowed. It gets auto heap allocated, which means that when my borrow checker in my head goes, this is not allowed, it actually means, oh, this one gets heap allocated, and I should think about the performance implications. And I think for C and C++, it's obvious in a way. You would not write a correct program if you did not have a rough borrow checker in your head, because you need to know whether something can be accessed, when it can be freed, whether pointers are valid, double freeze, all of that stuff, which is borrow checking.
So in Rust, when you see those error messages, you mean that they are helping you?
Yes.
It's not like they are on your way.
Not at all. I think of the Rust compiler as being sort of instructing you in constructing the right mental model yourself. I heard a good quote, I think it was from Nico Matsakis maybe, that Rust gives you the headache up front. So the idea is that you will have to fix these bugs. The question is just, would you rather fix them at compile time, or would you rather fix them 6 months later when your production system crashes? I know which one I would choose, right? But it does mean that it takes you longer to get to a running program, because Rust doesn't let you get away with making those mistakes even in the early days.
We're switching topic a little bit here. So what's the best thing about Rust compiler?
The best thing about the Rust compiler, I think it's the error messages. The fact that it tries really hard to be helpful while being concise, I think is relatively unique. And the fact that this is practiced so rigorously across the compiler, I think it makes a huge difference. It's something you see where when people try to pick up Rust for the first time, if they're programmers from another language, they get like outputs from the Rust compiler and they ignore them, and then they wonder, why did my program not work? And so often the answer is the compiler message actually told you. Whereas if you're a new programmer and you pick up Rust, you start reading the error messages and you go, oh, great, that's helpful, and you just do what it tells you to do. So I think it's one of those, like, I don't know if it's underappreciated because people appreciate it a lot, but it is a hugely helpful thing, and especially in a language where the learning curve is as it is, and there are enough weird concepts where you just need the compiler to help you.
So it's just enough to read them and figure out what's going on, you think?
So some of the time, some of the error messages also have links to these E-codes that give you a further explanation of a concept, and sometimes you need to read those. Sometimes you're just going to be lost, right? It's talking about some concept you haven't learned in your Rust journey yet, and you need to go read the book or something. But very often, the compiler message is sufficiently helpful that you can figure out what went wrong, at least, if not how to fix it.
When I'm talking about Rust with the developers in other programming languages, they, even if they're not very happy about Rust itself, they always mention Cargo, Rust Package Manager. They say that it's amazing, and they know about it at least. So is it really so amazing?
So I think the answer is yes, but I think the question becomes in relation to what? I think the reality is many programming languages have bad package managers. Or build tools. And Rust tried really hard to learn from all the lessons of the ones that existed at the time of its inception. And so it is maybe the best of the ones that are there. It's not clear to me that it's like the ultimate build tool, that you couldn't build anything better. But it is very good. Like, it very rarely gets in my way. There are a bunch of things that I think, Cargo could be better at, or where Cargo's behavior is maybe counterintuitive. Some of the stuff around Rust flags and cross-compilation, for example, that there are a bunch of like hairy depths of Cargo that I think are sometimes painful, or it's visible that they've evolved organically rather than as a principled, this is how we want this tool to work. But I think overall, it's a very good build tool. And it's a fantastic build tool compared to what people are usually coming from.
When I read the recent State of Rust survey, participant mentions that several biggest challenges when writing code in Rust, including slow compilation time, subpar debugging experience, high disk space usage. Do you think those are valid concerns? Is it possible to fix these issues?
Any concern that's raised by like more than 10% of respondents or more than 5% of respondents is a valid concern, right? And the question becomes, what can we do about them? So slow compile times is it's a property of a couple of different things. It's a property of Rust's use of an extensive type system, which inherently brings some amount of complexity to the compiler, which results in compile time cost. Some of it is the fact that you have many third-party dependencies, and so you need this more elaborate sort of distributed or topological build. Some of it is down to when you have multiple crates, you need more like link time optimization to make sure that if you have cross-crate dependencies, you still get inlining, for instance. So there's a decent amount of that kind of complexity. Those are hard to fix. It's not as though the compiler can't get faster. Obviously it can, but there's been a decent amount of work on optimizing the Rust compiler. And so the low-hanging fruit, I think, is mostly dealt with. And now it's more almost more fundamental things that need to change in order to make these things feasible. And not all of those come without trade-offs, right? Some of them might be that you get faster compile times, but you get a worse resulting binary, like less optimized. And even just the difference between cargo build and cargo build -- release is an example of this. Cargo build runs much faster, but you end up with a slower binary. And there are probably more levels of that pyramid we could explore. The large disk usage is partially related to this, partially related to the lack of automatic cleanup, although that has now landed in cargo, I believe. So now it will start to prune its own cache. And it's partially related to monomorphization. So you end up keeping multiple, like in the compiled binary artifacts, you might end up keeping multiple copies of data structures and functions just because they're generic, and you need to keep the generated intermediate representation or assembly code for each instantiation of that type or method. And so that obviously inflates the disk size. So valid concerns, yes. Can we do something about them? Some of them will be harder.
I need to ask this question about Rust macros. Some people say that they are heavily overused in Rust community, and they create a lot of issues for a compiler, and even especially for slow compilation time that you've mentioned. So is it really the case? Are there issues with these tools or not?
Macros are really useful, right? They're useful both in your own crate for things like avoiding repeating yourself a bunch, but they're also really useful for library vendors to give a better experience, like a better user experience, better ergonomics for your library. I don't know that I agree that they're overused, maybe in some spaces, but usually people go to a macro because there's not an obvious way to do it without one. And part of this is maybe lack of certain features in Rust that mean that a macro is the only way to do something. And where that's the case, we should try to improve Rust itself to make that not be necessary. But very often, the users are the ones sort of saying, I want the macro because I want this particular user experience. And so it's not like the developers are putting in macros just for fun. It's because that's what's needed to give that user experience that they want to give. I do think maybe there's an overly strong inclination to use a procedural macro rather than a declarative macro, because in a way they're easier to write, right? Just because you get to write actual Rust code rather than the slightly weird macro syntax that people need to absorb in their brains. But partially also because they are more powerful, and so you can do nicer things with them than you're able to do with a declarative macro. But sometimes that's just lack of creativity maybe, or lack of knowledge in how to really massage declarative macros. I think really this is a trade-off question, right? Because procedural macros do come with a potentially significant compile time cost. And the question is that additional compile time cost worth the improvement in ergonomics? And sometimes we probably make that trade-off in the wrong way as library authors. But I don't think the answer is to throw them away entirely. I think some of this is going to be figuring out how we can make procedural macros be faster. How do we improve the compilation model so that they're actually feasible to use to the extent that we want to use them?
What's your editor of choice when it comes to writing Rust code?
Oh, this was easy. So I use NeoVim. I've been a Vim user for many, many years, and now I use NeoVim. And I've tried IDEs up through the years. The first one I think I tried was Eclipse, and that was an experience. And none of them really sat right with me, but I think it's maybe because I have a very terminal-focused workflow. So on my computer, I only ever really have two windows open, and it's my browser and my terminal, and nothing else. Everything happens in the context of those two programs. As a result, it feels very weird to me to have an additional window open that is my UI, because so often I want to do things on the terminal, and if my editor is in my terminal, it's very easy to switch out of. So like the number of times I quit and reopen my editor in a day is like all the time, like several times an hour. Because I exit, I run some command, and then I enter my editor again, and that's fine. And that's the workflow that's like built into my brain and my hands. So it's very hard to get out of. Trying to move to an IDE, I mean, I know I can get a terminal in the IDE, but that's a subpar terminal, right? I want my full screen terminal with the full TUI and like everything is terminal. And so then having an editor inside my terminal makes more sense to my brain somehow. Although I acknowledge that IDEs have a richer graphical space in which to render your environment, which gives you more expressive power. But I just haven't found it to be a drawback. Like I haven't found things that I just cannot do in my current editor that I would like to do. And that could be lack of exposure, right? Like if I really tried an IDE for a month, then I would discover all these things that I can't go back to a terminal editor for. But at least at the moment, that's just not a need that I have.
Have you ever tried Rust Rover, JetBrains IDE for Rust?
I think I tried it for a solid 30 minutes. So no, I think is the real answer to that. And again, it's because there's nothing that draws me to them. Like there's nothing I feel like I'm missing in my current experience.
How many lines do you have in your NeoVim config?
It's not that bad. It's like 500 lines maybe. But this is like 500 lines that includes defining all of the plugins that I want to use and their configuration. So it's like, that is a fairly decent size, but it's not as though it's unmanageable. It used to be in Vim script, and then it was a pain. And then recently I rewrote it to be in Lua, and now it's actually decently readable.
Do you think that Rust as a language is a good fit for general software development pipeline, like these modern CI/CD practices, like some cloud infrastructure?
There are some things that can be a little annoying. Things like if your CI is set up to capture all of your test runs, like think JUnit, for example, then you can't do that with cargo test. You have to use something like cargo next test, which has a way to emit JUnit information. And some of it, so some of it is like not as native as maybe we would like it to be. And there are other bits like setting up test coverage requires figuring out like you need to use something like cargo LVM cov or something. So there's certainly a bit of you need to find the right tool to get those things to work. But that's already the case in other languages too. It's just that the tools are more established or more like already built into platforms. So I think there's a delta here of we could make the experience better, and I think we should, but I don't think it's like fundamentally lacking the capabilities for most of this stuff.
And what do you think about using Rust alongside other languages? Like, does it have a good connection to them?
Depends on the other language. Rust is fairly friendly to foreign languages, right? So you see this a lot in the Python space, for example, and in the Ruby space, where they increasingly now write native modules in Rust instead of C and C++, because it's all just a C ABI anyway, and so you can just write it in Rust and then use it the same way from Ruby and Python. You see it in the C and C++ world, where you can pretty easily use a Rust module, and you can pretty easily use a C module from Rust. The C++ and Rust compatibility is still, I'd say, in its young phase, right? Like there's more we can do there to make that more ergonomic. Stuff like CXX helps a lot here, the CXX crate. That feels like a space where there's room for it to get a lot better. I know was it last year that there was sort of an investment into the Rust Foundation specifically to improve this. And I think that is a good investment, because I think that's somewhere where it's not like the integration there is worse than it is for other languages, but it's that it feels like it could be better because the languages have some similarities that it feels like we can make use of. I think interfacing with things like Java, it's less clear. Like having to use JNI, for example, is you can do it, but it's a little bit painful. It comes with overhead. So that one I think is workable, but not the best. But in a way, the answer I just gave is Rust actually interoperates with a lot of things, right? If you took Java as the example here, trying to get Java to cooperate with Ruby, for example, or well, Ruby is maybe a bad example because you have JRuby, but with Python is probably more painful because you have two runtimes that are competing for the ownership of resources.
Several years ago, Graydon Hoare, which is original creator of Rust, he wrote blog post with this title, "The Rust I Wanted Has No Future." It looks like there was some engineering dream originally, and now Rust is a mainstream language. Do you think that Rust is missing something because of this transformation?
I think, first of all, that article is really good and people should read it if they haven't. The kinds of points that Graydon brings up there are not so much things that he thinks are wrong with the Rust programming language. It's just that if he were like the benevolent dictator for life of Rust, choices he would have made that is not what Rust ended up making. And as he acknowledges in the post, some of those are probably for the better, where the community made a better choice than he could have done based on, at the time, the conviction he had himself. And then there are some things that he just disagrees with, and there are some things where fundamentally there's a trade-off, and he prefers one trade-off, and the community ended up preferring the other, and which trade-off was more correct is like anyone's guess. But the fact that Rust has seen mainstream adoption to the scale that it has suggests that many of the trade-offs were made in the right way. So there are some things where you might end up with a cleaner language from like a programming language perspective, but that a cleaner language is not the thing that gets you adoption, right? Sometimes you actually want to favor the more complicated thing because it gives you more flexibility in the programs you can write or the performance you can achieve, and you're willing to pay the complexity price. And so again, like Graydon talks about this in that blog post of places where he would have made a different call, but it's not clear that would have made a better language. It would just have made a different language.
If you see something going on with Rust and you're not happy with some of the decisions, what would you do?
Well, so a lot of the discussion about Rust happens in the open. It happens in RFCs, it happens in pull requests and in issue tracker things. It happens in the Rustlang Zulip. It happens in the Rust users and internals forums. There are a lot of sources to monitor if you want to keep track of everything. But in general, like when I come across either a feature that I care about, a bug that I'm missing, or a feature that's announced and where I'm interested, I tend to go find the underlying thread and I subscribe to it over time to monitor it for, are there things here where I might feel strongly about something? And then there'll be some discussions where I see the feature coming and I go, I don't think this is the right call. And then I will jump into that thread with my reasoning for why I think it should be different. But it's not as though I go into those threads and then have the authority to just decide. That's not how it works. Usually, like the people who put in the time are the ones who get to decide. Like, let's take cargo as an example. I'm not on the cargo team. I'm not spending most of my time contributing to cargo. I have strong opinions on build systems, and I can provide those opinions and provide as much evidence or experience into those opinions as I can, but I don't get to make the choice because I haven't devoted the time and effort needed to get to be the person who decides. And so that means that sometimes they'll make decisions that I disagree with, but that's okay. That's how a community works, is that one person doesn't get to just decide.
But in general, do you like the way Rust is taking, like about the whole evolution of Rust? Are you happy with it?
I think Rust is, broadly speaking, on a good trajectory. I don't feel like I've seen lots of very objectionable decisions. There are obviously pieces here and there where I disagree with one call or another, or where I disagree with maybe with prioritization, where I think this thing should have been done before that thing. But I think overall, it's not like I feel a deep sense of like the language has gone astray. Not at all. I think it's on a very good path.
What is the leading force in Rust development? Is it community or maybe big corporations these days?
I don't think big corporations actually have that much sway over the direction of Rust. Certainly, if you look at the way the AWS Rust team worked, that was very much a fund people to work on Rust and do what you think is right for the language. And then there was some amount of like, they needed to argue for why these priorities also mattered to AWS for AWS to continue paying them. But it wasn't really AWS says you must do these things as much as it was, very senior people on the Rust team saying, this is what we believe we should be doing and why, and then articulating that to AWS and then going, okay, great, that seems reasonable, go do it. And I think it's the same with like Meta, for example, which use Rust extensively, but also contribute to Rust. I don't see them deeply affecting the trajectory of Rust. A lot more of that resides with the individual teams. And there are some of the team leads in the larger Rust team that are paid by companies, but at least the ones I've interacted with, I don't get the sense that they're doing so based on a sort of steering from their company. Quite to the contrary, the reason they were hired was because they had a strong sense of judgment to begin with and a strong technical capability. And I actually think what I've seen so far, I would expect that if they felt a strong steer from the company that employs them, they would rather either leave their team lead position or leave the company than allow that steering to really take foot. So I'm not really seeing a sort of commercial steer of Rust to any significant degree.
If Rust disappears tomorrow, what would the world lose?
Well, it depends how literally you take your prompt here, but I don't think there's an obvious replacement for Rust. I think we have a lot of non-obvious replacements. We have languages like D, which never really took off because it was a bit of a pain to work with. We have languages like Zig, which are like, Zig is very good at basically the subset of Rust where you write unsafe, but it doesn't really have a safe version to capture the places where Rust can actually buy you additional safety. And so it would fill maybe the unsafety niche of being a better C or C++ in that space, but it wouldn't fill the safety part. And we have languages like Julia, which tries to be a sort of, it allows you to write high performance code, but it also is pretty safe and stuff, but wouldn't really fill the like, can you run this on cars? You probably wouldn't run Julia there. And so I think we would be left with a gap, a vacuum that needed to be filled by something. And maybe that's an extension to an existing language, but I don't see what would go there. Maybe the closest one would be something like Swift, but Swift has the problem that it favors more things at runtime than compile time, and it's also very strongly controlled by one commercial entity, which I think is to the detriment of wide adoption. Like, it would be hard probably to adopt Swift in aerospace, for example, because the language is so tightly controlled by Apple. And I think this is one of the features that Rust has, is that it's not as tied to one vendor.
If Rust disappears tomorrow, what would you personally lose?
I would lose a community, I think. Like for me, the work stuff matters less. I think I could be a programmer in any language and it would be fine. I think I could be an educator in other languages too. But what I would lose is that community of people who care about this intersection of things that Rust tries to give, and that are interested in taking on a programming language that is harder in some ways because they care, they think it's interesting, they think it's fun. And I don't want to lose that community.
I think that was the last question. But by the way, you mentioned your book Rust for Rustaceans, and we happen to have it in our library, in our JetBrains library.
Yeah.
So I would like to ask you to sign it for us.
Of course, I'd be happy to. Now, the interesting thing here is you have to decide which page you want the signature on, because there's a big debate in the community about whether the signature should be on the first page or whether it should be next to the name.
Let's make it next to your name.
Next to the name.
Next to the name.
All right. So I also, I number all of the signatures so that every signature is unique. So this is book number 120.
That's amazing. That's amazing. Thank you. Thank you so much.